Hi everyone, I'm Andr Rodrigues and I'll be presenting our work on promoting self-efficacy through a human-powered smartphone task assistant for blind people. The problem is not that smartphones are inaccessible per se for blind users. It is rather how interfaces are complex and often very different from one another. To learn how to use a new app, blind users have to dedicate more time to learn the interface, take longer to find items due to the slow process of listening to sequential items, or resort to sighted assistance to facilitate the process. Adopting the device and learning new apps requires significant more effort and time for blind users. We argue that the most important aspect is not how fast you can accomplish a task, but rather how confident you are to experiment and continue experimenting until you master it. As Bandura described, unless people believe they can produce the desired effects by their actions, they have little incentive to act. Efficacy belief is therefore the foundation of action, and therefore we should seek to create solutions that, in addition to facilitate learning, they should promote perceptions of self-efficacy. To this end, our work focuses on the following research questions. First, can we create an effective human-powered smartphone task assistant, one that relies on users with no accessibility knowledge to create content for blind users? Secondly, if this happens, does the smartphone task assistant affect the perceptions of self-efficacy? Remember, that is not solely about if the user can or cannot. It's about if they believe they can and having the confidence to keep trying when it takes longer or when facing a challenge. I will briefly describe how we went about building our human-powered task assistant. We set out to design a rich smartphone task assistant that would, among other things, for the authoring process not require any training or professional assistance, streamline contributions to enable sighted contributors with no accessibility knowledge. As for the task guidance, we focus on providing flexible assistance and path recovery when users were guided through tasks such as ordering a burger on Uber Eats. The authoring procedure is really straightforward. After selecting an app, contributors are requested step by step to first describe the interface they are in and then actually simply perform the step. This behavior is repeated until the author has done the whole task. A quick glance at the task assistant. So, after someone demonstrates a task through our assistant, which we call Risa, people can learn that particular task.
Ativado. Começar.
Selecione biblioteca.
Dica. Vídeo. Pesquisa. Conta. Como é feita uma privada. Dica.
No canto inferior direito.
Dica. Como é feita uma privada. Chaves. Biblioteca. Botão. Listas de reprodução.
What happens is that users are guided step by step and they can go to the top of the screen to request additional information, which cycles through a list of hints that are adapted to a particular step, app context, and user paths and interactions. When they get to the correct path, an audio cue is played. If a wrong step is made, another cue is played. And what you just listened to or viewed is a basic overview of the basic behavior of Risa, which I described here. So with Risa, we conducted a user study where we first recruited 13 sighted participants to use Risa and demonstrate how to do 6 tasks in these top 6 Android applications. So Netflix, Uber Eats, Google Translate, Outlook, and OneFootball. The tasks vary from checking a team squad in OneFootball to ordering a Big Mac on Uber Eats. Then we recruited 16 blind participants to perform these 6 tasks, 3 with Risa and 3 without. We had 2 sessions in each participant had 2 training sessions followed by the condition with Risa or without. Tasks and conditions were counterbalanced. We collected demographics and smartphone expertise in the briefing questionnaire, and after each session, participants filled a self-efficacy questionnaire designed based on Bandura's work. We collected observations, Risa recorded interactions, and we had semi-structured interviews. We used the mixed effect models to analyze the task success rate and a pair sample t-test for analyzing the answers to self-efficacy questionnaires. We conducted a qualitative analysis of our collected data using primarily a deductive coding approach, since we are looking specifically into accounts of concepts related with self-efficacy. So first, our findings. RISA was not thought of as an assistant that would support a methodical exploration of structure, but rather as an alternative to it. Particularly for novice users, it was described as an easier way to get familiar with the applications by performing the tasks while ignoring the rest of the features of the application that could cause additional workload, allowing people to learn from actually performing the tasks they wanted, moving away from the current status quo of and requiring less effort. With RISA, participants successfully completed 72% against 10% without RISA, and we found a significant effect on participants' success rate. So, answering our first research question, can a human-powered non-visual task assistant enable effective smartphone assistant for blind users? The answer is yes, and it outperforms the alternative of free exploration and sheer effort. Next, when we assessed the self-efficacy reports, we found a significant difference between the one completed after using RISA, with an average of about 91, and without it, with an average of about 79, where higher means higher perceptions of self-efficacy. And more importantly, from our qualitative analysis, it is clear that participants with RISA feel they are more in control and often refer it enables them to do tasks in a more timely manner, stating that with RISA they would be more confident. For example, P4 say, for me it's difficult to explore new applications, but maybe with RISA I would be more confident. And so, answering our second research question, does effective smartphone task assistant affect users' perceptions of self-efficacy related with their smartphone competence? Our result suggests yes, it does. So, in summary, despite smartphones being considered accessible to blind people, many are restricted to engage with a mere handful of applications and device features for a fear of failure and doubt in their own abilities to overcome barriers and challenges. RISA was not only effective in supporting blind users learning new smartphone tasks, but more importantly, it improved their perceptions of self-efficacy and confidence with the device. We argue that moving forward, upcoming technologies should actually strive to provide systemic task-based support focused on facilitating learning and promoting self-efficacy. Before I finish, I would like to thank you all who had a role in this work. Thank you to all of the participants and to all of the institutions that supported this work. Thank you for listening.